So we're going to look at the idea of rounding. So we think that rounding is just a simple thing, maybe that we always go this direction or that direction, but at its most basic, it's actually fairly arbitrary. So why do we round up or why do we round down? Why do we pick one or the other, right? So really this has to do with a lot of purposes. A lot of times we think about in basic elementary school with basic math and smaller numbers, like we have 3.6 and we want to round that to 4, or we have 3.2 and we're going to round that to 3. Why do we do that? Why do we pick to go to 4 or to go to 3 simply based upon 6's relative position to 5, and same thing with 2 in those decimal spots? How come we're not rounding both of them to 4, or how come we're not rounding both of them to 3? And the answer is it really has to do with the situation that we're in. As a general rule, we teach small children to round up at 5, after 5 and up, and down with below 5, because we want to get them used to the idea of understanding the size of those numbers. That's one of the primary purposes of doing at that age group, at small children. But when you get into bigger situations, this becomes a lot less arbitrary and a lot more meaningful of why do we want it to round to 3? Or would we prefer, or would it be more useful for us to take 3.2 and round it to 4? What situations make that more useful to us or more meaningful? So let's talk about this rounding up. We actually have a function for this. We actually have another function for rounding down. And the thing with both of them is if we're going to round up, what we actually have is something that we normally write kind of like this. Okay? And the idea is that this is called our least integer function, which means simply round up. That makes sense. And it may not. Another way to call this is our ceiling function. You say, well, how can we be rounding up? It says least. Well, it's kind of backwards. We're saying it's the least integer that's still larger than the number we're dealing with. For instance, we have 3.3. What's the largest integer still large, or what's the smallest integer still larger than 3.3? 4. 4 is the largest integer. Pardon me, the smallest integer still larger than 3.3. Okay, we're rounding up. What about 4.1? Once again, we're going to round up. What are we going to round up to? We're going to round up to 5 because we're wanting the smallest integer that's still larger than 4.1. Where would we want to do this? How is this useful to us? Why would we ever want to round up like that? Well, what if we're talking about cars? One car will only hold X number of people. So if we have 3.3 people, well, that's actually kind of gross, I guess, right? Then we need a fourth one, right? So if we're talking about putting things into a box, we have, or we're talking about lifting up something that's fairly heavy, okay? And our forklift can only lift up 3 tons. Well, we need the fourth forklift, right? If each forklift can only lift a ton, then we need to round up because we're over 3 tons. So we need a fourth forklift to lift up those tons, or a jack. If we're talking about lifting up a car, well, how much more do we need? So if we're talking about rounding down, we actually have another function for that. And this is what we call our greatest integer function. Now these seem backwards, right? And the idea with this is if we had 3.3, we'd actually round that down to 3, because in this instance what we actually want to do is we want the smallest, strike that, we want the greatest integer that's still smaller than this number, okay? So if we're talking about going back to 4.1, the greatest integer function, or the floor function of 4.1 would be 4, because we want the largest integer that's still smaller than what we're dealing with. So if we continue this, we talk about 4. What's the largest integer still smaller or equal to that number? 4. Okay? So these are situations where you're talking about rounding up or rounding down has real world applications to it, and maybe we do it differently based upon what our situation is. We're talking about putting children onto a bus. The bus will only hold 30 people. Well, if we have 33 people, we need a second bus. We have to round up. If we're talking about the weight of something, we might need to round up, right? And then we have other situations where we might need to round down. And It's just based on the different scenarios that we have. So when we talk about basic rounding, we normally talk about there being that arbitrary 0.5 right there that moves us one direction or the other, up or down. But there are actually functions where this actually has other applications to it. So yes, this is rounding, and then there's also a thing called truncating where we just remove the decimal entirely. But this allows us to be able to figure out what the unit value that we're counting with is here. So another way to think of this is how are we unitizing the values here? Here we're saying the unit value is being counted in terms of 1. If we have more than just a little bit of 1, we have to round up, and because the unit value is there, is going to be counted a little differently. I hope this is useful, and I hope it's helpful. Reach out and let me know if you have additional questions.